Okay, folks, welcome. Uh, this is going to be our first page of notes for Chapter 6, Work and Energy. And the first thing we're going to be highlighting here is that we're really trying to stress that when we talk about this idea of work, which we're going to get into in a second, we're talking about work. Well, work is energy. And when we're talking about energy, energy is work. They are the same thing. So that's something we need to be comfortable with utilizing throughout this entire chapter here. So, chapter 6, Work and Energy, really gives us an opportunity to reframe our analysis and the language that we're using when we're talking about similar events. So, up until now, we've primarily talked about whether or not things are accelerating and how that acceleration is actually occurring through the usage of kinematics and dynamics. So, our kinematics are our constant acceleration equations with initial velocity, final velocity, acceleration, time, and distance. And then dynamics is your Newton's second law, Newton's first law. Sometimes some Newton's third law sprinkled in as well. So our entire year up until now could basically be said as net forces cause masses to accelerate, which again is literally Newton's second law. So we can still talk about the same phenomena, something undergoing some sort of a change in speed, speeding up, slowing down, whatever. What's causing that speeding up or slowing down to actually occur and quantifying it. We can do the exact same thing, but with different sets of language that would be using. So instead of talking about kinematics and dynamics, we're going to be talking about this same idea, but through the lens of work and energy. So what we would say, instead of net forces cause a mass to accelerate, speed up or slow down or turn, we would say forces do work, this new idea, which we're calling work being done to an object, and that's going to change the energy of the object. So again, going back to work is energy, energy is work. So doing work because a force caused a push or a pull will cause the energy of an object to change. So in terms of the essentials we need, so work, again, when a force is acting on an object, it causes them to speed up or slow down. This is how we're defining it. We say that work was done, really stressing the change in language here. So when it comes to energy, when work was done to an object, we say that energy was transferred to or from that object. Not necessarily just how much energy does it have, but how much energy did it gain or how much energy did it lose? By how much did its energy increase? By how much did its energy decrease? Right. So when we're talking about energy, we may be somewhat familiar with one type of energy, our kinetic energy, which is our energy of motion. And whenever we're talking about energy, we're talking about units of joules, 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 capital J. All right. Now, when we're talking about work being done, a force is doing work. We can have positive work that's done. We can have negative work that's done. So positive work means that the energy that we possess increased, so it went up, or we could say energy was transferred to us, causing our overall energy to increase just by positive work being done. Negative work is going to be the opposite. So that would cause our energy to decrease, which means energy was transferred away from us. And since we're connecting energy to motion, we would say when positive work is done, my energy increased, like my kinetic energy. So that would mean I'm going faster. I'm speeding up. My speed is increasing. And then the opposite can be said when negative work is done, we'd be decreasing. So tying this idea of work being done to motion, positive work is increasing the rate of motion. Negative work would be decreasing the rate of motion. So there you go. There's a quick intro to work and energy for you. So if you have any questions, please make a note. Feel free to ask, and onwards we go.